Okay. All right, so Kate's going to talk about rasters. Thank you all for being here.
Hi, I'm Kate Tiedeman. I'm a fourth year PhD in ecology in Robert Hyman's lab, who builds the raster package and makes it, so I'm hopefully not going to embarrass us all too badly. I guess first I'll talk about sort of what a raster is versus vector data. Has anyone had experience working with rasters before? Yeah. Okay, cool. For those of you who haven't, vector data refers to sort of thinking about the world and spatial data as a series of either points or lines or polygons. So that could be something like country boundaries or borders. It could be streams for the lines or points for, say, point data, like for your bumblebees. I'm presuming, no? Bees? Regular bees? No. Okay, cool. Whereas a raster or raster data is sort of a different way of looking at the world, which asks sort of a yes-no question in a grid, I would explain it as. So you're essentially making a grid of equally sized cells, we'll call them, whatever size you feel is appropriate, which is sometimes rather arbitrary, where you're asking, is this vector data in or not in the grid? Or is this line feature in or not in this guy here? And you can do that in sort of different ways. It doesn't have to just be 1 or 0. People use this a lot for land use lane change, or land use lane cover, excuse me, where something might be continuous. Rainfall is another really good example. All of the Google Earth Engine data, this is a land cover example of the United States. All of the Google Earth Engine data comes out in raster format. So when you're looking at something like slope or reflectance or something like that, it'll be in typically these like equally spaced cells. So reasons you might want to do this, you've got this continuous data. Maybe you're interested in something like change over time, or you are interested in a unit of analysis that isn't quite covered by vector data, something like that. So what I'll go through today is loading raster data, and I'm going to do this in a more complex way than I think is great. Rasterizing, reprojecting, and then I'll go through a little example that the lab wrote up, and I'll go through one that I wrote up about using raster data to look at change over time. Yes, from this. The first thing you'll want to do is definitely load up your raster package. So what I'll also go through here is we'll extract the annual average rainfall in Tanzania. Sorry. And this is all publicly available data. And it's coming in monthly data, so that's something to think about. So setting my working directory and path and listing the files. So this is going to be a list of vector data, or a list of TIFFs or raster data for precipitation from 2003 to 2014, I want to say, for each month. So the first thing I'll do, since I'm going to ignore the fact that this is going to be stacked data that we'll look at all together, is just read in one raster. So I'll just take the first one in the file, or first one in the file list. So this reads in your raster. And then the next thing I'll take a look at is I'll check out the attributes of my brand new baby raster, which is here. See? So things we're interested in here. The dimensions, the number of rows, the number of columns, and then the total number of cells here. The resolution, which in this case is the WGS 84. We're also interested in the extent. So this is sort of like the bounding box of your raster, the max, min, I want to say it comes in, but we'll go over that later. And then you'll be interested in the coordinate reference system, because you can definitely reproject your raster. This comes with a name as well, and then the values, the minimum and the maximum for this raster in particular. So other things you might be interested in, maybe you want to plot. So this is the raster data, and it comes in this basic terrain thing where it's from 0 to 606. So this is the rainfall in East Africa in January of 2003. So other things you can do, you can ask for the extent of this raster, even though it's in the summary. You can get the extent by itself, which is really helpful because you can access this with extent at xmin and stuff like that if you want to create a new raster with that same bounding box. Maybe you want to know more about the values. You'd like to know about the frequency of each of these. So this is similar to the table function in base, which gives you the value and the count of each one. So this is super helpful for something like land use, land cover data, where you're interested in, say, like how many of each category are in certain things. Sorry, keep scrolling all the way up. So the value and then the count here. So this is the amount of rainfall. A lot of areas apparently had no rainfall up in that white zone. And then very few had a ton. You can also plot a histogram of this fairly easily if you're just looking to take a look at your data. Beautiful. And let's say you're just interested in one country. This is going to unfortunately take a few minutes, I think. You can read in a Tanzania shapefile. This is just from the get data. This is the country level, which I can plot also. Beautiful. And then you can check the CRS and then use it to you can use it to mask or clip. And there are a couple different ways to do this, but the way I'll show is mask.
Could you increase the font size a little more?
Definitely. Maybe.
Control plus, I think. Plus.
Scroll up.
Yeah, control.
Control is not my friend right now.
Control scroll. What is it? Scroll up?
Scroll down.
Oh yeah. Try that, I guess.
No go.
If you go to tools and then global options.
Up here.
It's also view.
Screen size plus
There you go.
Great or horrifying?
Much better. Thank you.
Great.
Yeah.
All right. So this is using mask to clip the raster to just Tanzania, which is going to take a second. And then you can plot it and see that you just have the Tanzania values, which have now gone from 0 to about 300. So let's read in the whole raster stack so we can mess with it a little bit. So this is going back to the list of files I have called FF, which is just a list of all the files in this folder. Precipitation for all of...
Yeah, sorry. With the CRS, if they don't match.
You can reproject it really easily. Yes, and it's down here somewhere. You can do project raster, and where this would be your original raster, which is S, and then the CRS you're looking for.
Do you need to manually type that in?
No, definitely not. You can just use CRS equals CRS of whatever shapefile or raster you want to. Although if you're doing it for a raster, I believe it has to be in all caps.
Okay. Just because it comes with the package or something.
Yeah, I'm gonna say yes. Yeah.
Cool.
One more question about CRS.
Mhm.
Can you point us to a resource where we could get more details about the CRS?
The different projections.
Yeah.
Yeah, you're gonna be the one for
I'll
that.
send one along. There's a few. They're not great, but they list everything. They just look stuff up. Yeah.
Mhm. So this would be reading in this big raster stack. And we've sorted it here by name so that it's read in as 2003.1, 2003.2. So there's one, each year and month are together, basically, each year by month. So taking a look at that, we now see this sort of extra bit up here, which is number of layers when we read in a stack. So there are 132 layers. That's 11 years of 12 months. And still the same things, looking at the resolution, the extent, and the coordinate reference system. And here now we have the names of each one. So we've organized this data so that it is monthly, but that's worth checking. You may need to order it by something else.
Do the extents need to?
Yes. Otherwise, you can merge them if you'd like to, which just sort of like smushes stuff together as long as it's in the same CRS. Yeah.
Is there a drawback to doing the merge versus reprojection?
You'd have to reproject anyways to merge. They have to be in the same CRS, definitely. But that would be more for something where it's like the same time step or something like that, but different spatial extents. That makes sense. So then plotting for something like this, here we're only, this is very tiny. This is the font size. We're only going to see the first 16. That's sort of the default. But here you'll see we go through all of 2003 and then all of 2004. So if we want to just plot the first three. Very beautiful. So then digging into this, maybe we're interested in something like the mean or the annual sum or something like that. So this function called stack apply is kind of a pain in the butt, but it's taking our raster stack and indexing it. This is going from 1 to 12 and then taking the mean for that. So it'll just go 1 to 12, 1 to 12, 1 to 12, 1 to 12. So it'll give us the average of all the Januarys, all the Februarys, all the Marches, all the Aprils, etc.
You were missing a data for some reason, would that throw everything?
Yes, definitely. You'd want to add in another layer of like an NA or something like that, probably. So here's rain month. And we can do a lot of things with this. This is, sorry, going to take a minute. That we would do with just regular data frames and stuff like that. So this one will take the names of the stacked rasters and rename them into month name, which is already in our raster stack. So now instead of 1, 2, 3, we have January, February, March, April, May, etc. And then maybe we want to plot that. So these are now the averages for each month from 2003 to 2014, which is kind of cool. The next thing I thought I would show you, so another thing you can do is like raster math is super simple like this. You can take the sum, so the sum of the rain month, and then you have the total, what would this be? The annual, the sum of the monthly averages, which you probably wouldn't want to do. But let's say instead of that, you want to do the total amount of rain per year in this area. You do something like the stack apply and then repeat it 1 to 11 for 12 times. So that's indexing each one, where it's 1, 1, 1, 1, 1, 1, 1 for the first year, 2, 2, 2, 2, 2, 3, 4, 5 to 11. That'll also take a second. So then what I'm going to do, because I'm interested in like say change over time, and you can do this with your point data, which I've done before but was not able to find in time for this morning, where you aggregate your point data into rasters and then do a regression where time is the independent variable, which is kind of fun because then you can plot the betas and see if there are any spatial patterns, and then you could use that to look at something like, I use it for kelp, so distance to the shore, something like that. So then we make a little guide time, which is 1 to 11. So it's 1 to the number of layers in rain year. And then this is just a really simple little function where if it's NA, we ignore it. And then otherwise, we take the raster stack and we regress each one with time. And we'd spit out the coefficients too. If you wanted to get the intercept, you'd spit out 1. Did I do that right? Yes. And that's unfortunately going to take a second. Yeah.
You said it again, which we're taking, you're looking at the temporal trend, basically.
Yeah, for each cell.
For each
so this
cell.
it'll bring out, it'll take each cell in its stack and assign it the time as well, and then do a regression with that, basically. And what we're spitting out here, hopefully one day, will be the beta. So it'll be like each cell will have a beta. Yeah, so each cell will have a beta and an intercept, which is pretty cool. And error, I think, that you can pull out of there. With just about anything. Like you can write your own functions with this guy. You can take the average, you can take the mean, the standard deviation, anything you'd like. That's sort of the beauty of raster math in a vectory world. Another function I'll talk about while this is running, which I think is super cool, and I may or may not show you, is the focal function. So let's say you think that your values are super peaky, and you're not quite sure if you'd like to maybe average them or something like that. Or in my case, I'm looking at where agriculture is and is not, and there's a lot of error around that. So I'd have a cell, and like, let's say this cell is agriculture, and the cells around it are all not. Like I'd have maybe some reason to doubt that. Multiple data sources, and they're saying this is or isn't agriculture. What you can do is take a focal average, where you identify the cell, well, for each cell, you look at the 9 or 15 or however many around it, and either average it or sum it or do anything you'd like, basically. So you can say, let's say I'm only interested in these where the surrounding ones more than half are agriculture. I take the focal of the raster and then sum it, and then if it's above whatever, I'd say it's agriculture, basically.
So is that return a point statistic, or is it return another raster?
It returns another raster. Almost all the stuff returns another raster, except things like frequency, which you can make return as a data frame if you're interested in that. I might piece out of this one.
We'll post up code and everything later.
We'll pretend this was super cool. Another thing that was really cool to do with this was earthquake data. So looking at how earthquake data has changed over time. This I don't think I'm going to show you.
How has earthquake data changed?
I'm sorry?
How has earthquake data changed?
Not the way you'd hope. I was at the time really trying to relate it to fracking events. So I was looking, I rasterized everything just as a quick first pass and didn't see any earthquake data change above, magnitude above 4.5, I believe. Since fracking's increased over time, I was like, well, okay.
What about below that?
Yeah, I didn't look below that because there were so many.
Yeah.
And then I abandoned the project, as one does. Another thing you can do, and what people usually start with when you look at tutorials with this, is making your own raster. like a blank raster to rasterize like your shapefile data or your point data. So this I'm not actually going to run, but the get cover is a really fun formula, I guess, because when you rasterize your vector data, you'll be asked to sort of summarize it in some way. You can do counts or sums. You can do the average. In this case, I think this one's super cool. This is the get cover function, where you've got your raster in a shapefile. What it'll do is divide each of these into 100 cells, so 10 by 10 cells, and then say, is it in there, yes or no? Is it in there, yes or no? And what you'll get back is a % cover, essentially. So you get back, this would be 100. This might be like 20, something like that. So I think that's really cool for something like land use, land cover. We've used it for the kelp cover as well.
This KNR.
These would just be, this would be your shapefile and then your raster. Yeah. Is there anything else I wanted to show you? You can do this with points as well. In this case, you'd be taking the mean, but you can also do the sum. I think that's kind of all I had, but this is making a new raster right here, where you can define the number of rows and columns and then the extent that you want, or you can do it by defining the cell size that you'd want. And I think that's all I had, other than rasters are great. Thanks.
Can you scroll back to the get cover?
Mm-hmm. Oh God. Here. So in this case, this is my kelp data, which is going to take way too long to run, but it's a kelp shapefile from Oregon, Washington. I'm just taking the first one in this path. And then making a raster of with the extent of the shapefile, and then adding 2 to that and making the cells 100 feet squared. Or 100 by 100, pardon.
So your initial raster is just blank, it's just like the setup.
Yeah. Which is really cool because you make it whatever size you'd like, or you can go out and get it like from Google Earth Engine and do the 30 meter by 30 meter pixels, something like that. Yeah, and then I'm going to put in a plug for helpful things, which are Robert's tutorials on rasters and raster manipulation.
We just had a question on what is the difference between a stack and a brick?
Shoot, I always mess this one up. A stack is layers of rasters all together. And a brick is, I believe, a stack of a stack. Am I saying this correctly?
Okay.
Yeah. Yes. So, what do you think?
Both lists, probably.
The bricks.
The list of lists.
Well, yeah, like a brick, the way I think about it, at least, or the way I use it, is in Google Earth Engine, it'll give you a number of bands, 1, 2, 3, 4 for whatever year, and then band 1, 2, 3, 4 for another year, and a brick is putting that all together.
So
Different extents. It all has to be, the annoying part about this is it all has to be the same extent and same cell resolution. But that means that it's all directly comparable if you want to do something like a regression or sum or cell stats or focals. And you can do that across the stack as well. I don't know if I made that super clear. You can get like the mean of the means and stuff like that. Really simply.
Thanks.
Yeah.
So you showed that you can rasterize point data.
Yes.
Like why?
Why?
What's an advantage of it?
Well, an advantage of it, I guess it's, for me, it's using it in these linear functions and being able to look at trends and stuff like that. So I used it at one point to look at eastern gray squirrel versus western fox squirrels and seeing if their numbers were changing relative to each other in the same area at the same time. What's an advantage of doing that? It's a summary statistic, basically.
Yeah, I can imagine from that.
It's somewhat arbitrary though, like the size and shape of your raster determines the answer you get in a lot of ways, or the size and resolution of your raster. So it's important to think carefully about what your unit of analysis is and why.
Yeah, so if your point is really tiny compared to the
Like you wouldn't make a 1,000 or a 1 kilometer grid if you just were looking at like squirrels on campus, maybe. Yeah.
Here's some info on raster stack and raster brick that says that raster brick can only be linked to a single multi-layer file, whereas a raster stack can actually be formed from different files or different band or layers. And then a stack is typically, or a raster brick is more efficient when you're processing than a stack.
That is something I'm also supposed to say, that processing is easier this way. Yeah. I have and have not found that. Like, as you can see, some of this stuff takes a long time.
Yeah.
And Ryan's going to show us the SF package, which is way faster.
Well, it's vector, mostly vector-based though. So. But it's
yeah.
I mean, operating in vectors tends to be faster than rasters regardless. So.
Which I should have also shown you, is in almost all of these, instead of making them an object, you can spit them out to a file if you think you don't have the processing power to keep that in your memory. So where's a nice example of that? I may not have one.
I have one other good question.
But you can just spit it out like at the end of this.
So the question is some questions about the focal function, but somebody wanted to know if there's a different use case for using focal versus extract with a buffer.
Ooh, that's interesting.
But does extract with a buffer do a similar thing?
So extract is something I also should have showed you but didn't, where you have like say a number of points or something like that you're interested in, and like say in Tanzania I do a lot of ground truth sampling, and you're just interested in say like the characteristics for those areas. So extract will let you extract or take out raster values for each point, and it will spit out not a raster but a data frame that you can attach to your spatial points data frame, or you can make it spit out as a spatial points data frame. Buffer, you would presumably have like a circular situation as opposed to this. It just depends on what you want to do. Right. So you can extract with a buffer and take the mean or something like that. Whereas this one, you'll come out with a raster with a value for each cell, except for the border cells, obviously, because they wouldn't have enough. Yeah. Cool. So it depends on what you want to do and what data format you want to stay in.
Yeah.
Cool.
Awesome. Thank you very much.
Cool. One more question.
Oh,
yeah.
So if I'm pointing you to that figure, that grid and shapefile. So if I was to use the shapefile to mask out a raster, what would happen to the grid cell with 20% coverage? And can I manipulate it to extract the 20%?
My memory is that anything that touches this stays. Okay. For mask. And that you're not cutting that off. But I don't remember entirely. The way to get around that is to use extent of the shapefile if you wanted to do something like that. Or crop.
So that's going to
crop.
Be the box, right?
Yeah, so you could crop by the box around the shapefile if you wanted to cut it down that way. That's a good question about the mask function. I don't remember.
there are ways, and so using the SF package, you can clip specifically to something that you could potentially rasterize it or play with it, so.
Yeah, but if you wanted to like hold on to this 20, I don't remember if it keeps the whole cell here or if it just
Right.
keeps this bit. I'm sure you can play with it actually, to keep or not keep it. Yeah. Cool.
Any other questions? Awesome. All right, we're gonna.
Sorry, I have a question.
Yeah.
So when you want to clip, maybe you said this already, but if you want to clip a raster with a vector.
Yeah.
Right? I think I had the problem that it will like add myself
Mm-hmm.
up. So how do you make sure that they're, with the entire pixels and it doesn't, because that happened to me once and then it was changing the values because it would.
Oh.
Can you rephrase or just say
Sorry.
the question so you're on the recording? Yeah.
So the question was, how do you clip and maintain all the values for the shapefile? Is that the?
Yeah, the values of each pixel.
Mm-hmm. And my answer is probably that that's in the mask help documentation, but not in my brain. The one way I talked about where you crop around the extent of the shapefile is a good way to do that, but then you might be left with some NA detritus on the side. Yeah.
So crop or mask.
Yeah, crop and mask. Cool.
All right.
So you don't have
to. Awesome.
And yeah, Ryan will put all this up in a clean version.
Right.
Maybe.